All right, well, continuing on with quiz chapter 3B on projectile motion vectors. I have a small cart rolling at a constant velocity on a track. So I have this cart traveling at a constant velocity in this direction. That is that the acceleration is equal to 0. It fires a ball straight up into the air as it moves, and after it's fired, what happens to the ball? So I have this ball, and it's fired straight up into the air. Now remember that the ball also has the velocity of the cart, so it has the same velocity of the cart. So as the ball goes up, it continues traveling with that velocity. So when it comes back down into the cart will have moved the same distance in the x direction as the ball. So it's going to fall right back into the cart. That is D. Now the cart is being pulled along a horizontal track by an external force. That means that it's going to accelerate. So the acceleration is greater than 0. At a certain point, you let go of the ball and it has a certain velocity, which is the same as the velocity of the cart when the ball is shot up into the air. And the ball will follow the same path, but remember that the velocity here is always going to remain constant, whereas the velocity of the cart will be increasing as it moves to the right. So the cart then will be here because it'll be moving at a faster rate when the ball falls. So it will fall then behind the cart. We drop a package from a plane flying at a constant speed. So here's my plane. It drops a package out of the plane, drops it downward, but the plane has a certain velocity and the package has a certain velocity in the x direction. And so the result is that this package is going to follow a parabolic path like that. We're assuming no air resistance. And the plane will be exactly over the package as it falls because they both have the same velocity in the x direction. So the answer is B. From the same height and same time, one ball is dropped and one is fired horizontally. So I drop a ball, I fire a ball. They're going to take these paths. Now this one has Vx equals 0, and this has some Vx greater than 0 because I'm dropping one and shooting the other off to the side. But their Vy's, velocities in the y direction, are the same. They're both 0. So the time required to fall is going to be the same for the dropped ball and the fired ball. And so as a result, they're both going to hit at the same time. So they both hit at the same time. That's C. Previous problem, which ball has the greater velocity at ground level? Well, because the fired ball has an additional Vx component, is going to have a greater velocity. So when they hit the ground, if I draw their vectors, the dropped ball is going to have that velocity, but the fired ball will have those vectors. So this one is going to have the greater magnitude. So that's going to be B, the fired ball. Okay, angle 30, projectile launch, angle of 30 degrees. At what point of the trajectory does this projectile have the least speed? This angle is 30 degrees. At the top, the velocity in the y direction equals 0. Everywhere other place, the velocity in the y direction is not 0. So the least speed is at the top. Now it doesn't have 0 speed because it has a velocity in the x direction, all right, but it has the least speed. So that is at the highest point in its flight. That's B. Which of these punts has the longest hang time? Remember, the time in flight is governed by the height of the projectile. So in this case, they all have the same height. And since we use the y displacement to determine the time in flight, then they're all going to have the same hang time. So that's D. Battleship simultaneously fires 2 shells at 2 enemy submarines. Same initial velocity. Which one gets hit first? Well, again, we can look at the y distance. So here I have a bigger y distance than here. So that means that the time for this one is bigger. It has a bigger time because it's higher up. It goes higher. So that's going to be A. Cannon on Earth, the cannonball would follow path 2. However, on the moon, where the acceleration due to gravity is smaller, what path would the cannonball take in the same situation? If it accelerates at a lesser rate in the y direction, that means that it's going to fall at a lesser rate. And so since it's falling at a lesser rate, it's actually going to travel further. So that's going to be 4, or D, as it will be. Spring-loaded gun can launch projectiles at different angles. What angle should the projectile be launched in order to travel the greatest distance? We talked about this. It's 45 degrees. Let's go back up to this, actually. So there are a whole range of angles. This is 45 degrees. It's going to give you that path. If I have a lesser angle, it'll go a lesser distance. And if I have a bigger angle, it will go higher, but it will go a lesser distance than the 45. So 45 is the maximum distance that you can get, the maximum horizontal range, but not the maximum vertical range. All right, you were trying to hit a friend with a water balloon, he's sitting in a window, you aim straight at him and shoot, and just when you shoot, he falls out of the window. So you're trying to shoot something at somebody, and just as you start to shoot it, he drops down. All right, but this thing is also dropping down. So the projectile is going to follow a path like this, but when it reaches this point, this guy will also have fallen the same distance because they're falling at the same rate of minus 9.8. So the answer is yes, it does hit. Similar here. The answer is yes, it hits. You fire a projectile and it follows a path like that. And he falls at the same rate. And so they meet at the same point.